Hello everyone, my name is Taryn Turner, and for my research project I will be covering ocean acidification. Ocean acidification can be described as a process that lowers pH levels in the ocean due to carbon emission and ocean absorption. Due to the significant increase carbon emission from human activities, the ocean's pH is decreasing. This process began with the Industrial Revolution, and while habits taken in and refined from this era have made life easier, the mass chemical release has left its mark on our environment. It is scary to know that the pH was this low 14 to 17 million years ago, when life on Earth was much different than it is now. The rapid change since then has left scientists progressively worried. In just under 200 years, the ocean's pH decreased from 8.2 to 8.1. It seems insignificant, but that is a 30% increase in acidity. According to the European Environment Agency, the global annual mean atmospheric CO2 concentration exceeded 417 parts per million in 2022, which is more than 40% above the pre-industrial 200. According to the European Environment Agency, the global annual mean atmospheric CO2 concentration exceeded 417 parts per million in 2022, which is more than 40% above the pre-industrial level, 280 parts per million. Half of that increase has occurred since the 1980s. In this research article, Ocean Acidification, the National Climate Assessment studied 3 different things in a particular region. The red line represents the increased carbon emission, the blue line increasing represents the carbon intake, and the green line decreasing represents the ocean's pH. The article also states, currently, the oceans absorb about a quarter of the CO2 humans produce every year. Over the last 250 years, the oceans have absorbed 560 billion tons of CO2, increasing the acidity of the surface waters by 30%. For ocean acidification to occur, there's an obvious chemical process. First, atmospheric or released carbon is absorbed by the ocean. Once it is absorbed, carbon and water chemically mix. This chemical mix forms carbonic acid. The chemical formula for this is 2 hydrogen atoms, 1 carbon atom, and 3 oxygen atoms, or H2CO3. After this, hydrogen and bicarbonate ions are dissolved from the carbonic acid, and once these numbers increase, the ocean acidity increases as well. This would usually be a normal process, but because of the increased carbon emission, it's messing it up. With the increase of hydrogen and bicarbonate ions, carbonate ions, which are different, decrease and impact calcifying organisms. These particularly vulnerable organisms include oysters, shellfish, clams, sea urchins, shallow water corals, deep sea corals, and calcareous plankton. The impacts that they face are reduced calcification, decreased energy management, disruption of food webs, shell or skeletal dissolution, and coral bleaching. To elaborate, reduced calcification means calcifying organisms aren't able to form calcium carbonate skeletons and shells. This is an obvious problem because their bone support or their primary defense mechanisms build incorrectly. Decreased energy management refers to marine organisms having to use more energy to fulfill bodily functions. This leaves less energy for growth, reproduction, and basic survival. Because of most of the listed problems, food web disruptions occur. A decrease in many aquatic species is correlated to this as well. Coral bleaching is a big visual impact. This is a symptom of dying corals and refers to its loss of color. In the visuals provided, there are before and after pictures. In the before picture, this is a 1980s representation of what coral reefs look like. Now you can see that it's bleached and looks unhealthy in the current representation of it. For other marine organisms, or non-calcifying ones, negative changes can be seen as well. Non-calcifying organisms include fish, algae, seagrasses, jellyfish, sponges, some plankton, and some worms as well. While these effects are dissimilar, they are still just as dangerous compared to calcifying organisms. These impacts include physiological stress, developmental issues, reproductive impacts, and behavioral changes. To elaborate, physiological stress refers to the disruption of internal pH, metabolic processes, and sensory perception. Developmental issues stem from hormonal changes from the acidic changes and decreased energy management, like discussed before. This leads to the next problem of reproductive issues and impacts. Hormonal and developmental problems lead to a reproduction decrease. Behavioral changes include reduced ability to sense predators, impaired navigation, changes in feeding behavior, decreased activity levels, and even altered habitat selection. In this case study, Impact of Ocean Acidification on Marine Species by Dr. Justin Rise, there are two visuals provided. On the left of the screen, here is a normal shell with a normal carbon intake, and here is a shell with a high carbon intake. For this shell right here, you can tell that the color is a lot more vivid and the lines are a lot more rigid. It's a lot more defined and overall just healthy looking. For this shell, you can tell that it's obviously bleached. It's not as defined as the other one. It looks a lot more dissolved than this one over here. And for this visual, the negative, parabolic, and surprisingly positive shell growths are recorded over time from ocean acidification. Overall, this case study explores the impact on marine organisms for shell bleaching and their shell growth. Like mentioned before, there are impacts on food webs. These can occur in various ways. For shelled organisms, ocean acidification makes it harder to build up shells, which is their primary defense mechanism. This makes them more susceptible to predators and decreases survival and reproduction rates. Without the supply of these organisms, predators are either left with no food or finding outside sources of food, which will disrupt the food web. This happens with other marine organisms as well, and while it's not the same and they are not shelled, their defense mechanisms are becoming less useful as they become more and more disoriented in acidic waters, making them more susceptible as well. Another impact includes the overall decrease in nutritional quality of aquatic organisms. If marine organisms aren't able to fulfill their nutritional needs with regular prey, they may face growth issues or must adapt to more food resources. There are multitudes of impacts on the environment. Under the sea, coral reefs are dying. This is detrimental as coral reefs house and support millions of marine species. If coral reefs continue to undergo this, fish cannot gain their nutrients or find habitats. Severe food web disruptions can occur as mentioned. Extinction and eventual loss of biodiversity will occur because of the lack of food and habitats and adaptation problems. Another impact is a change in the chemical makeup of marine organisms. Like the changes in internal pH mentioned before, similar things can happen through other chemical imbalances in the body. This can lead to negative changes for the organisms themselves, the food web, and the marine ecosystem around them. Above the sea, shellfish and other organisms contaminated can directly impact consumers and fishery companies. Water consumed that is contaminated and more acidic can be harmful for humans as well. The food web above the sea can face changes too. As groundwater and soil gets contaminated with acidic water, plants that grow from the contaminated resources can impact its makeup and nutrients. This can severely disrupt the food web and environment for all animals, including humans. In different regions, the acid vulnerability varies. For polar regions, like Alaska, ocean acidification is a hot spot for this process due to the cold weather. Cold water absorbs carbon faster than in warmer temperatures. In upwelling zones, or places where cold, deep ocean water is brought to the surface, carbon-rich waters can intrude surfaces and lead to more acidic waters. Coastal areas vary in acidity and are more so dependent on the environment around them. Freshwater input from regional rivers and localized pollution in that area are the main contributors. For equatorial regions, there are high carbon saturation levels, which result in less acidic water. Ocean acidification can influence change in biogeochemical cycles. This refers to the process by which chemical elements and compounds move through Earth's systems and the changes that occur as a result. One effect is a disruption in the biological carbon pump. This means that the ability for the atmosphere to store and release carbon will be significantly reduced. Ocean acidification can also potentially disrupt and reduce the carbon storing process of the deep ocean. Ocean circulation systems can be disrupted because of the changes in the water's density, temperature, and salinity. The decreasing number of calcifying organisms like phytoplankton, crucial to the carbon cycle, can impact things outside and inside the ocean. The carbon and other chemical cycles can be thrown off as a whole as well. Marine organisms and environments hold a big part of the global economy. In the U.S. and Canada alone, the net present value of impacts through 2100 to U.S. consumers is about $11.3 billion US dollars and $850 million US dollars for Canadian consumers. For the aquaculture companies, grave impacts can be felt. As the contamination of marine life increases and the nutritional and taste quality of the food decreases, these companies may lose a lot of money. In the future, fishery companies may not even be allowed to serve the foods that they are mass producing now because of the contamination. In specific, shellfish and oyster companies will suffer the most. The marine economy is already seeing a decrease in the numbers of shellfish and other shelled organisms. In the scientific article quoted before, the future of shellfish numbers and impacts of the economy are discussed. We find that U.S. consumers experience damages far greater than Canadian consumers, as waters off the coast of both countries become warmer and more acidic. There are many things scientists are doing to try and help the problem. These include using bipolar membrane electrodialysis, which is a newly developed technological process that uses electrical fields and ion exchange membranes to separate and concentrate ions. Farming organizations and volunteers are coming together to plant carbon-absorbing organisms in the ocean like kelp and some algae. More research organizations like the Global Ocean Acidification Observation Network are committing to the monitoring and future solutions of ocean acidification. An obvious attempt is trying to reduce carbon emission by using renewable energy and new energy-efficient technologies. Examples include solar energy and electric cars. There are other practices scientists are doing to increase the alkalinity of the ocean. While scientists are a big part of the solution, you sitting at home can make a change as well. You can make ecologically smart choices like using less energy overall at home. Examples of this include turning off electrical appliances like lights when you're not using them, use LED bulbs, use natural light when possible, insulate your home, seal air leaks, use a programmed thermostat, and use less hot water, like when washing clothes. Choose more sustainable transportation options like carpooling or electric cars. And that is obviously not an option for everyone, and that is okay, but just drive when you need to. You can conserve water as well. At home, stop just letting the water run like when brushing your teeth or washing dishes. Fix leaky water pumps and hoses. Only run big appliances like dishwashers and washing machines on full loads. And collect rainwater for outside use. Recycling is a big part of this as well. Recycling lowers the amount of waste and carbon emissions. Make more conscious purchasing decisions. It is a big trend on social media now to just buy so much stuff that is unnecessary, but it is super wasteful and horrible for our planet. Do you really need that $600 Shein haul? No, you don't. Think before you spend. This leads to the next point of buying eco-friendly products from vegan and environmentally friendly companies. This plays a big part in waste reduction. I have all my work cited listed here, and that'll be the end of the presentation.